Okay, so coming to discrete probability distributions. There are a set of discrete probability distributions, guys. Under discrete probability distributions, there's Bernoulli distribution, there's binomial distribution, there's Poisson's. Okay, there are and many more. Under continuous comes the Gaussian and exponential, uniform, and all those. Okay, yeah. As of now, in this video, I'll just stick on to what Bernoulli's trials or Bernoulli distribution is like. Actually, there's a statement about Bernoulli distribution, that is a random variable x, a random variable x that takes values 0 and 1 with a probability Q and P respectively. Okay, what that is P of x is equal to 0 is Q, P of x is equal to 1 is P. Okay, or in other words, I can write like Q is equal to 1 minus P, or P plus Q is equal to 1. Okay, this is Bernoulli's distribution. Now, I'll just talk about one example and then come to what exactly the formula goes like for Bernoulli distribution. That is, there's an example. If we toss 10 coins, what is the probability of getting 7 heads is the question. Okay, there's an example. What's the probability of getting 7 heads? How do I proceed, guys? Okay, for this, there's a shortcut like your binomial. Of course, the Bernoulli binomial. Okay, what does this binomial theorem say? If I have something power n, it's NC0. Suppose if I have x plus y power n is NC0, x power 0, y power n, NC1, x power 1, y power n minus 1, and it goes on and on. Okay, or I can write NC2, x power 2, y power n minus 2, and so on. Okay, it goes like this. So, I look at this problem in that way. How I will look at this problem is, just see. Let n be 10. Okay, guys. And then what's that I want is R. Okay, 7 heads I want. Okay. So, if P is probability of success, what's P here? Probability of success. What's probability of success? Getting head is probability of success. Getting head. What's the probability of getting a head? 1 by 2? Yes or no? If Q is probability of failure, or Q I know, once I know P, I know all the remaining things. It's 1 minus 1 by 2, which is 1 by 2, right? Now I'll write it like this. Out of 10 trials, 7 heads should come. 7 heads can come in how many ways, guys? Out of n trials, out of n trials or n experiments, R successes can come in how many ways? In NCR, P power R, Q power n minus R. P is success, so P power R. Q is failure, so Q power n minus R. So the solution to this problem will be 10C7 into 1 by 2 power 7, 1 by 2 power 10 minus 7. Okay. So like this I will be solving, for which I'll be needing the Bernoulli distribution or the binomial distribution. Mind you, guys, before actually we have Poisson's distribution. Before going to Poisson's distribution, all of us should know that by Poisson's is the limiting case of binomial distribution. Even normal distribution or Gaussian distribution is the limiting case of binomial distribution only, because of which you ought to know what exactly Bernoulli's distribution or Bernoulli's trials are. and then how I will do using binomial or Bernoulli distribution. Okay. So here I can write like what I can write here is probability of R successes out of n trials using binomial distribution. I'll be writing like this. But for using binomial distribution, I will write here first and then go to the other points that I wanted to discuss. Getting R successes out of n trials can be done in NCR into P power R into Q power N minus R ways. It can be done in this ways. Now, to apply binomial distribution or Bernoulli's trials, there are a set of assumptions which you ought to know. Let me list them out. First thing, the conditions or limitations to binomial distribution. If I can apply binomial distribution, then what should be the conditions? Every time I toss a coin, it should be under the same environment. That means what first condition is trials are repeated under identical conditions. Identical conditions. For the first toss and the 10th toss, all should be same. Okay. Identical conditions. Say I'm doing it for n times. Okay. Every trial has only two possible outcomes. Only two possible outcomes. What are they? Success or failure. Okay, only two possible outcomes are there, not in dilemma or the third case. Okay. Next thing is each trial is independent of the other. All the trials are independent. The trials are independent. Okay. I mean, the first trial does not depend on the previous one. It is like that. In this case, I'll be using binomial distribution. These are the limitations or these are the conditions where I can use binomial distribution. You ought to know about binomial distribution because Poisson's is a limiting case of binomial distribution. I'll talk about that and few more things about binomial distribution in the next video.